Another type of algebraic expression we'll deal with is not a numerical one, but a variable-based one. So what we want to do is we want to take this big, long expression and we want to simplify it down as much as possible. So the first thing I want to do is simplify anything within parentheses, but when I look inside the parentheses here, here, and here, no set of parentheses has like terms that I can combine. Remember, like terms have the same variable involved. All right, so what I'm going to do is I'm going to do the distributive property here. So I get 5 times 2x is 10x. 5 times negative 3y is negative 15y. 5 times 1.3 is 6.5. Then I'm going to do the distributive property again with the negative 2x. Negative 2x times 4x, negative 2 times 4 is negative 8. X times x is x squared. All right, and then negative 2x times negative 2.9 is positive 5.8x. All right. And then I'm going to have one more distributive property here, distribute the 3. All right, so 3 times 2.1x is 6.3x. And then 3 times negative 6y is negative 18y. And 3 times negative 4 is negative 12. So I've eliminated all the parentheses using the distributive property. Now I want to go through and I want to try to identify like terms. Now I'm just going to go in alphabetical order. So let's see. I've got a 10x here. And I want to see if I have another x anywhere. And I have a 5.8x right there and a 6.3x right here. So I want to combine these terms together. So 10 plus 5.8 plus 6.3. Let's see, 11, 12.1, 22.1. 22.1 x's. Okay. Now let's see. Oops, sorry about that. Now I want to take a look to see if there are any other like terms. All right, well now I've got a minus 15y. And I have a minus 18y over here. So negative 15y minus 18y is negative 33y. All right. Are there any other like terms? So now if I take a look, I've got a constant term of 6.5. And I've got a constant term of negative 12. 6.5 minus 12 is negative 5.5. And now I've used everything except for this one lonely guy in the middle right here, negative 8x squared. I'm just going to throw him at the end. These terms do not have to be written in any particular order. There's no set order that you have to write them in. I know I said I was going to go mostly alphabetical, but that x squared kind of got thrown in at the very end there. You just want to make sure that every term gets considered when you're simplifying an algebraic expression, okay? Now, simplifying algebraic expressions leads right into solving equations. So let's take a look at solving some single variable equations. We're going to solve each of these equations. Now, they look pretty complicated, but they're not going to be too bad because they are all single variable equations. Taking a look at the first one, step 1, get rid of the parentheses. So I'm going to have 5x plus 7x minus 28 equals, I'm going to distribute the 5 to get 15x plus 10 minus 2. All right, so then from there on the left, combine like terms to get 12x minus 28 is equal to 15x and then plus 8. I'm going to choose to subtract the 12x over. So I'm going to do minus 12x minus 12x. So that will be gone. And I'm also going to do minus 8 to get rid of that. So now I'm going to have negative 28 minus 8 is negative 36. And that's equal to 15x minus 12x is 3x. We're going to divide out the 3 to get to negative 12 is equal to x. And that's my final answer. There is no need to check your answer here, but you could take your answer and plug it back into the original equation to make sure it works, which just means that the two sides of the equations will be equal to each other, right? For this second one, problem number 9, I've got 4y minus 11 equals, I'm going to distribute the 3 to get 6y plus 12, take away 2y. I'm going to combine like terms on the right, so 4y minus 11 equals, let's see, 4y plus 12. And now an interesting thing happens on this problem. I'm going to subtract the 4y from both sides, but it's going to cross off on both sides. And that's going to leave me with negative 11 is equal to 12. Well, that's not a true statement. these are not equal to each other, so that tells me that this equation actually has no solution. There is no number for x that will work here, or rather for y, sorry, there's no number for y that will work here and give me the same thing on both sides of the equation, okay? So sometimes you'll have no solution. The opposite of no solution will be infinite solutions, or all real numbers. And that would have happened, say, if it had been -11 equals a -11, or if it had been 12 equals 12, a true statement after the variables eliminated off. Okay, let's take a look at 2 more solving equation problems. All right, one thing you're going to have to get very comfortable with this year is fractions, but we don't usually like dealing with fractions very much. So what we're going to talk about with these 2 problems is how do we make the fractions disappear? Because we all know that it's a lot easier to deal with an equation when there just aren't any fractions involved. So the trick we want to use is we want to identify what is the least common denominator for all of the fractions. So I want to look at all of the denominators and say, what number can all of these numbers go into? Well, 3 times 4 is 12. 12 is a denominator. 2 goes into 12 as well. So the LCD is 12. Now you have 2 options. Option 1, take each term and multiply it by 12 over 1. Because as long as I do the same thing to all the terms, it's still the same equation. Option 2 is rewrite everything so that there is a common denominator of 12, and then pretend like the 12 never existed. Okay? Now that probably sounded really confusing, but let's see what it looks like in practice. I'm going to go with option 1. I'm going to take this entire equation, I'm going to multiply it by 12 over 1. So let's see, I'm going to do 2 times 12 is 24 over 3k, which reduces down to 8k minus. Then I'm going to do 12 over 1 times 1 over 4. So 1 times 12 is 12. Over 4 times 1 is 4. Well, that's just 3. 11 over 12. So 11 times 12 is 132. But then divided by 12, we get back down to the 11. And then 1/2 of 12, 12 over 2, is really just 6. Okay. And now I have a much simpler equation to solve. Actually, So I'm going to add 6k to both sides, add the 3 to both sides. I'm going to end up with 14k is equal to 14. Divide out the 14 from the k, and you get k equals 1. Okay? All right. Now, I misjudged my spacing here a little bit, so let me just slide all of this over. Hopefully I got it all. There we go. All right. Let's take a look at problem number 11. Same idea. I'm going to go through and figure out what the common denominator is. Now, I'm going to put this guy over 1. My LCD here, 1 times 4 times 5 is 20, and that is the smallest denominator I can have that both 4 and 5 will go into it. So I need to multiply every term by 20. So I have to do 3 times 20 is 60. All right, now this next one's going to look a little weird at first. I'm going to do 20 times 2x minus 1. I'm going to divide it by 4. I'll explain why I wrote it that way in a second. I'm going to do 20 times 2 minus x over 5. So I multiplied everything by 20. Now, why did I leave it like that? What are you doing, Miss Morrow? Well, right here, 20 divided by 4 is 5. So I can rewrite this equation as 60 minus 5 times 2x minus 1. I don't have to distribute the 20, right? And similarly, over here, I can do the 20 divided by 5 is 4 times 2 minus x. And now I just have distributive property to work my way through, all right? So I'm going to have 60 minus 10x plus 5 equals 8 minus 4x. All right, so I'm going to have 65 minus 10x equals 8 minus 4x. I have to slide it up a little bit so that we can see. All right. I'm going to add 10x to get rid of this. I'm going to take away the 8. So I'm going to end up with 57 equals, what is that, 6x divide out the 6. And that's going to give me x equals 57 over 6. Ignore those directions down there. 57 over 6. And that reduces down. 57 and 6 are both divisible by 3, and that gives you 19 over 2. So that's the final answer. We want to get in the habit of simplifying our fractions completely whenever possible. Okay? So that is solving equations.